All right, let's jump straight into this explainer by putting you right in the thick of it. Imagine you're an emergency room physician. You're standing in the middle of a chaotic, totally overwhelmed trauma center, and you are staring at a high-stakes clinical dashboard. Now, historically, you'd rely on your years of brutal medical training, established clinical guidelines, and honestly, your own human intuition to triage the patients rushing through those doors. But today, your hospital has rolled out a state-of-the-art triage algorithm. It's instantly scanning electronic health records, crunching real-time vitals, and spitting out a score that decides exactly who gets a bed and who gets sent to the waiting room.
So right there on your screen, the machine makes its call. For patient A, a person actively gasping for air with severe trauma, the AI recommends delay care. But for patient B, who has a severe but absolutely non-life-threatening fracture, the AI says immediate ICU admission. You've got exactly 45 seconds to make a life-altering choice. The system insists this decision maximizes, quote, net clinical utility. But here's the catch. This AI is a total black box. It can't explain its math to you, and you have no idea how it weighed the variables. So the agonizing question is, do you trust the algorithm, or do you trust your own human empathy?
That brings us to Section 1, the proxy data trap, from cost to mortality.
To understand how we actually arrived at this terrifying algorithmic cliff, we have to zoom out and look at the systemic roots of bias. Building on our previous breakdown of automated racism, there was a landmark study published in the journal Science that exposed a really fatal flaw in one of the most widely used predictive algorithms in the US. This algorithm was supposed to flag high-risk patients who needed specialized care, but it made a massive fundamental error right out of the gate. It mistakenly used healthcare costs as a proxy for actual human health needs. Because of deep-rooted economic and social barriers, historically, less money is spent on Black patients compared to equally sick white patients. So by optimizing strictly for cost, the algorithm mathematically assumed that Black patients were just healthier than they actually were.
The clinical data proves just how broken this is. When you look at the severe disparities in actual clinical biomarkers, we're talking uncontrolled blood pressure, cholesterol, kidney function, the gaps are staggering. Despite having significantly worse physiological biomarkers, like much higher HbA1c levels for diabetes, Black patients were assigned the exact same risk score as healthier white patients. The algorithm was literally blind to human physiology because it was entirely obsessed with financial data.
And to put the human cost of this proxy trap into perspective, let's just look at anemia, which is a classic measure of chronic illness wear and tear. At the exact same algorithmic risk score, the gap in anemia severity meant a Black patient was effectively 14 years older than a white patient. 14 years. That is a massive physiological disparity, just completely hidden behind a clean, objective-looking math score. So let's bring this back to the ER. What happens when these administrative cost-predicting models get upgraded into emergency triage systems? Well, if a triage model is trained on historical hospital data to predict things like survival probability or how long someone needs a ventilator, it's ingesting those exact same systemic biases. It doesn't look at a human being in need. It literally converts past societal neglect into an automated death sentence. To the algorithm, a marginalized patient who is historically deprived of care just registers as an inefficient investment.
Which leads us to Section 2, the black box triage, hallucinations in the ICU.
So, what happens when we throw generative AI and large language models into these incredibly high-stakes mass casualty scenarios? We already know standard algorithms fail, but a recent study using the Triage benchmark evaluated 6 major LLMs on medical triage, and it exposed a deeply disturbing split. Basically, proprietary models, which are heavily safety-aligned by their corporate creators, tended to heavily overcare, meaning, to play it safe, they would over-allocate extremely scarce resources to patients with minor injuries. On the flip side, open-source models went in the completely opposite direction. They actively undercared, neglecting critical patients who needed immediate life-saving intervention. Look, neither of these approaches is remotely acceptable in a mass casualty event where absolutely every second and every resource matters.
But here is where it gets really crazy. Researchers discovered something they call the ethics paradox. You'd naturally assume that telling an AI to act ethically would make it perform better, right? Actually, scratch that. It makes things worse. The study found that explicitly prompting clinical LLMs with ethical frameworks, like telling it to maximize the greatest good or follow strict duty-based principles, actively degraded their clinical decision-making. Basically, reminding an AI of its moral context during an emergency causes its medical accuracy to plummet. It gets so tangled up in the philosophical framing that it forgets how to execute the actual medical triage protocol.
Moving on to Section 3, Machine Utilitarianism versus Bioethics, the Conceptual Revolution.
What we're watching unfold is a massive clash between cold mathematical efficiency and the actual bioethical duty of care. The World Health Organization is warning us that medicine is undergoing a profound conceptual revolution right now. Think about it. In the 20th century, the moral goal of medicine was pretty straightforward: heal the sick. But in the 21st century, when healthcare is increasingly governed by optimization algorithms, medicine risks devolving into a system that just wants to upgrade the healthy. If an algorithm's only goal is resource efficiency, it's going to divert care away from the elderly, the disabled, or the marginalized, who might mathematically be deemed to have lower quality adjusted life years. The terrifying prediction here: by 2070, this kind of algorithmic optimization is going to drive unprecedented, deepening healthcare inequality.
And this creates a huge legal and moral black hole. As the WHO points out, a physician might not have any idea how a black box AI is actually converting patient data into life or death decisions. Bioethicists call this the many hands problem. If a triage algorithm makes a fatal error, who do you blame? Is it the software developer, the hospital administrator who signed the check, or the doctor who was essentially forced to use it? Accountability gets so diffused that a dying patient is ultimately stripped of their fundamental right to a human explanation.
This takes us to Section 4, the Human Oversight Mandate, Regulatory Red Lines.
The good news is that global regulators are finally starting to draw some hard lines. Under the European Union's new AI Act, emergency healthcare triage systems are now legally classified as high risk. This legislation explicitly demands human-in-the-loop safeguards. Basically, a competent human being has to oversee the system at all times. Clinicians must have the legal right and, crucially, the technical ability to disregard, override, or totally reverse the AI's outputs. They even mandate a built-in stop button to safely shut the system down if it starts hallucinating. But let's be real for a second. How effective is a stop button in actual practice? When you're a fatigued clinician in a chaotic ER, you are highly susceptible to automation bias. It is incredibly difficult to actually second-guess a competent-sounding machine when every single second counts.
Finally, Section 5, the weight of choice, reclaiming clinical autonomy.
Ultimately, this human warranty in healthcare, this absolute requirement for human supervision, is not just bureaucratic red tape. It is a non-negotiable bioethical imperative. We simply cannot outsource our moral burdens to a mathematical formula. So I want to leave you with this final thought today. Because triage is at its core a moral burden and not a math problem, we have to ask ourselves, what do we actually lose when we delegate our empathy to code? If a triage AI was proven to be 15% more accurate at predicting overall survival than a human doctor, but it achieved that efficiency by systematically discriminating against the elderly, is it ethical to use? What is the true price of algorithmic efficiency? Take a moment to really think about that, and let us know where you draw the line. Thanks for joining me on this explainer, and as always, keep questioning the algorithms shaping our world.